didn't go quite as well as we had hoped. And of course, we have the demotivator countdown too, which actually makes for that last talk being kind of schizophrenic because we keep switching between the demotivators and the more serious stuff. So, grades. We got the exam grades were loaded. So you should be able to, if you do the view grade script, your exam 3 grades are there. The last 2 labs are returned. We have homework 7, 8, and 9 that are almost done. I know I've been saying this for a while. I'm going to spend some time a bit later talking about why some of these grades are so late. The other things that need to be graded are lab 12, which was due about 3 hours ago, so that hasn't been graded yet. Quiz 3, which was due last night, so that hasn't also been graded yet. And, of course, the homework, which is due in a day or two. I am hoping that by tomorrow night, homework 7, 8, and 9 will be returned. By Wednesday night, quiz 3 and lab 12 will be returned. And then by Thursday night, homework 10 will be returned. That is my plan. If that works, you should have about 24 hours from Thursday night to Friday night, from which all of your grades will be in, and all of your grades will be on the view grade script, and you can decide whether or not you do want to take the final. You'll also notice on the view grade script, it will give you your actual letter grade. So now as everything is returned and it modifies your average, if your letter grade changed, that'll be reflected there as well. As I mentioned, I gave everybody the +5 bonus on quiz 2. If you have submitted a regrade for quiz 2, you probably won't see the +5 bonus yet. I have to wait till all the quiz 2 regrades get taken care of before I add that in. But for those of you who have not submitted a regrade for quiz 2, you'll see an extra 5 points on that. So homework 10 is due tomorrow at 10 a.m. There is a 24-hour extension to that. So it's basically an extra 24 hours that you can work on it. So kind of effectively, it's due at Wednesday, 10 a.m., which means that the late deadline is Thursday at 10 a.m. So we actually can't start grading until Thursday at 10. That's why we're aiming to get it returned on that Thursday. This, of course, completes the course project. If for whatever reason your code doesn't work smoothly together, and these things happen from time to time because there's a lot of intricacies, one thing you might want to try to do is use our code and just plop in your descriptions class, because that was where all the customization was. As I mentioned, the final assignments will have a shorter regrade period, just because 10 days from now is about half a week after I have to submit the final course grades, so I can't give a 10-day period for submitting the regrade. Office hours will be today and tomorrow. There will be the normal office hours, although there will be extra TAs showing up to help. And then after tomorrow, means from Wednesday on, there won't be any more TA office hours, and myself and Professor Koh will only have office hours by appointment. Final exam. It's this Friday at 7 p.m. here in this very room. It is completely optional. If you do not take it, then the grade that you get will be the grade that is eventually reflected on the view grade script. I think I've said this before, but I hope that all of you will decide to opt out of the final because I really don't like grading. So I just heard a report that set visibility that we chatted about briefly on Friday is having issues. How many people are running into that? Okay, a couple people are. I heard about that about a half hour ago. I haven't had a chance to look into it. Other questions, comments, concerns? Yes?
How much could your grade rise with a really good exam?
Theoretically, if you were to get a, you know what, I have a formula for that, and I'm going to stick it on the website. There is a specific formula that I have that will tell you how much your grade could raise if you take the exam. Roughly, it's about, it can raise about a quarter of the way between, if you get 100, then it's a quarter of the way between your current average and 100. So if you have a 90 and you get 100 on the final, it's going to be like a 92.5, because that's a quarter of the way between your exam and 100. As a rough estimate, there'll be a more accurate, I think I did the math right on that, there'll be a more accurate formula on the website in a day or so. Other questions, comments, concerns? Yes? Say that again?
The error my homework is in the math trigger class.
For? Let's chat about that afterwards, because I haven't heard many other reports. That might be something specific to yours.
It's actually in their Mac class. I saw it many times on Sunday.
Okay, let's chat about that afterwards. Other questions, comments, concerns? Okay, yes?
Do we need to email you if we're not taking the exam, or that's not?
Nope, just don't show up. I will assume that anybody who is not here on Friday, or rather is not turning an exam, is getting an excuse as opposed to a 0. So no need to email me. For those of you, I have about 4 people in here who are graduating. I'm actually going to email them specifically because I need to know if they're going to take it or not, because I have to submit their grades early. So I've gotten some very useful feedback. This is actually good feedback. I've gotten some very useful feedback through the various course surveys. I don't see the toolkit stuff until long after the semester ends. But there's 1 or 2 things that I've gotten through anonymous emails or whatnot. And some people said that because we've been a bit late in returning some of the homeworks, that they're afraid that any mistakes they made on homework 7 might be repeated on homework 8, and because we didn't get homework 7 back in time, then the homework 8 grade might be penalized as a result. I'm going to do my best to avoid this, and I think I have a way generally to avoid this. So I would say don't stress too much yet. Wait till you get all the grades back, and then you can stress. And a lot of people said, I can't believe this is only a 3-credit class. You should make it 4 credits. I would love to, but I can't. There's actually a UVA policy that says for every 50 minutes of lecture, they call it an hour of lecture, but for some reason an hour equals 50 minutes. For every 50 minutes of lecture or every 3 hours of lab, you can count that as 1 credit for the course. Which means in order to make this a 4-credit course, then we would have to make the Thursday lab be a 3-hour lab instead of an hour and 15-minute lab. So UVA specifically prevents me from making this a 4-credit class. I'd love to, perhaps not surprisingly. I just wanted to mention that because a couple people have said that. One could certainly say, well, stop being so sadistic and assigning so much work. We'll get to that. So this is the final homework graph. Homework 10 doesn't really mean much because only about almost a 1/9 of the class has submitted it. So, all right. So we had talked briefly about inheritance, and then we went off into 10 dimensions. We talked briefly about inheritance, and I wanted to spend a couple more slides talking about some advanced object-oriented programming examples, and then I was going to move into the course reflection part. So we talked about using a computer game, such as a vehicle game, to go about using inheritance, right? You would have vehicle, and subclasses of that would be plane, train, automobile. Underneath plane would be space shuttle, helicopter, jet plane, what have you. Well, another example is a graphics program. If you have a graphics program, you could easily have a shape class. And a shape class, you could have underneath it a circle class, a cube class, a dodecahedron class. When I was doing my PhD dissertation programming, I actually had this hierarchy where I had a shape class and various 3-dimensional shapes underneath that as well. So this is another example when you might use inheritance. Remember that any method you define in the shape class, because the other 3 classes would would extend the shape class. They would inherit from it. If you add a get area method in the shape class, that would be also included in all of the subclasses as well. Circle, cube, dodecahedron. Dodecahedron is a 20-sided 3-dimensional figure. So inheritance, of course, as we talked about, organizes things in a semi-top-down manner, right? You have vehicle. Beneath that are plane, train, automobile. Beneath plane is space shuttle, helicopter, jet plane, what have you. We talked about the is-a relationship. A space shuttle is a plane. A plane is a vehicle. A mountain bike is a bicycle. So you can say a subclass is a superclass. An SUV is a kind of automobile. Actually, it's a kind of truck, but that's only to get around gas mileage constraints. A border collie is a kind of dog. A laptop is a kind of computer. So you have all these sort of is-a relationships, and that helps you define what is inheriting from what. If you're thinking of making something a superclass and something a subclass, the subclass is a superclass, such as a train is a vehicle, or a diesel engine is a train. So another thing I wanted to briefly mention is a concept called packages. You're going to see packages in cs101 for those who continue. And what a package is, it's basically a way to take a lot of classes and stick them all together. We've seen packages before, java.util.star. That's saying I'm going to use, or I potentially am going to use, all of the classes in the java.util package. We saw java.lang. That's the default package that has things like the system class or the math class. There's java.text, there's java.auth, and the Java SDK defines 30 or 40 different packages. Each one has anywhere from 2 to 100 different classes in it. So it's yet another way to organize things into some sort of cohesive whole. So we could say that in our game, the 12 classes we defined in our game could be grouped together in some sort of package. Blah, 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 blah. I'm going to ignore the whole thing about namespace and same folder. But the idea is a package is a way to group a number of similar classes together. Java.util groups a number of utility classes together, right? It has vector. It has, trying to think, what other ones have we seen from Java.util? String buffer. I mean, a lot of utility type of classes are grouped together, hence the name Java.util. So we've seen public and private. I now want to briefly mention what the other two are. Public means everything can access it. This column means that particular class. Subclass means anything inherited from it. So if something is public in vehicle, then any subclass from it, such as train, can also access anything that's public. Package means anything in the current package, and general means basically none of the above. So public, as we saw, anybody anywhere can access. Private, only that class can access. If you're outside that class, whether it's a subclass somewhere else in the package or somewhere in another package, can access a private variable or call a private method. And the other two we haven't seen are protected and default. Protected is much like private, except a subclass can access it. So maybe the vehicle class had a protected field. And what that's saying is that the vehicle class can use it normally, but and any subclass can, train, plane, automobile, space shuttle, but outside that, it can't actually access that particular field. So it's still controlling visibility, but it limits it only to that class and its subclasses. Default, sometimes called package, basically means that anybody in the package can access that particular field. So if something in the vector class, the java.util.vector, was package, we could not access it because we're not in the java.util package. So these are the other two visibilities that I hinted towards or that I talked about, but this is actually what they mean. Protected is just like private, except a subclass can access it. Default is just like public, except it needs to be within that same package. So ultimately, if you don't declare a superclass, meaning class foo, and you don't say extends, Java will automatically have it extend the object class. The object class is the parent or grandparent or ancestor class of every class defined within Java. The shape class has object as its ultimate ancestor. Your location class in the homework has the object as the ultimate ancestor. It's basically a superclass of all Java classes. So we say circle extends shape, so that's telling what the immediate parent is. We don't say shape extends anything, so Java automatically considers that to extend object. And it turns out that this is really useful for us. So everything extends object, either directly, class foo extends object, or maybe just say class foo and Java puts in the extends object, or indirectly. The circle class extends the object through shape, right? Circle extends shape, shape extends object. And it turns out that object contains a number of methods. Some of these methods you've seen. Clone, we've seen that one with the arrays in particular. Equals, the string dot equals, toString, and a couple others that we haven't seen in this course. All of these methods are ultimately defined in the class object. which means that every class in Java, whether it's one you define or somewhere else, will have these methods. And this is what's nice about it is there is a default toString method in the class object, and therefore every other class that you define, therefore every object that you create is going to have a toString method and a clone and equals and like half a dozen others. So that's what the fact that everything ultimately, its ultimate ancestor is object, that's one of the things that that gives us is the fact that there's a couple methods that we know for sure every object and every class will always contain. So clone is protected visibility in object, which means that if you try to call clone on something of class object, it's not going to be able to do very much. You're not going to be able to call it. Remember, protected means that only the class or its descendants can call it. So the circle class also has, therefore, a protected version, because when you inherit it, excuse me, dust in my mouth, when you inherit it, the visibility stays the same. Of course, protected means it's kind of like private. Code outside the circle class can't call it. So if we wanted to have a clone method, for example, a clone method in our circle class, we just have to create one and say it's public. And then anybody could call our circle class as clone. But you notice the return type. The clone class, as defined by object, says it has to return something of class object. So anytime we redefine it, we have to keep it the same. That's why clone always returns an object. Why the add method in vector always takes an object. Well, actually, I'll get to the add method in vector. If we try defining it differently, then we get some method, something like that. But essentially, the reason that the clone method always returns something of class object is because that's how it's defined in the object class, and therefore that's how it's inherited to everything beneath it. So equals always has that prototype. It's generally public, but it's Boolean equals object O. This discussion also applies to the add method in vector. So it turns out that many things in Java need to use the equals method, and because they need to figure out if two objects are really the same thing or different things, right? The vector class, et cetera, et cetera. If you want to search a vector for something, it's going to go one by one through the vector, checking, is this object equal to what you're looking for? No. Is the next one equal to what you're looking for? Is the next one equal to what you're looking for? So we need to know that the equals method will work properly. That's another reason it's defined in the object class. It's defined there, and then it will work ultimately in every subclass of the object class. And in particular, it needs to have the same prototype. When they define it in class object, they don't know what type of parameter it's ultimately going to take in. Maybe it's a circle. Maybe it's a location. Maybe it's another map printer object. So all they can say is that it's something of, it's just an object. And then that's what's taken in. They're going, and there's details of the equals method that we're not seeing here. But then it's going to check to see if that object taken in is, you know, a circle, and then if the circles have the same radii or whatnot. But this is why the add method in vector, or the equals method in really anything, always takes something of class object. It means that it's going to take any object, or anything of class object, or anything descended from class object. And so the nice thing about object-oriented programming is this will allow a circle to be taken in, because the circle is a subclass of object, allow a location to be taken in, because the location is a subclass of object, and allow a diesel locomotive to be taken in, because that's a descendant of train, a descendant of vehicle, a descendant of object. So this means anything of class object or anything descending from class object. ToString is similar. There's a ToString defined in the method in the object class, and therefore it's in everything. What ToString does, if you try to print out a object to the screen, it will call ToString and just print out whatever ToString returns. The default ToString is kind of dull and not really what we want, but the point is that every object will have a ToString method, either one that you define or the one it gets from the object class. So now consider this. In class foo, we have public string ToString and return foo. So here we have our toString method. We create a new foo object. We print that out. All right, this just sees a reference. It follows the reference to see if there's a toString method. There is. The thing is that there's a pair of toString methods in this class. There's the one that object included, and then there's the one defined right here. So it inherits one from class object. We don't say it extends object, but Java automatically puts that in for us. So class object defines a toString method. Here my class foo defines a toString method. So I have two toString methods included there. In particular, they both have the same prototype, public string, toString. So Java will always call the most specific one. So toString and foo is more specific. It's specific to that given class, whereas the object one is kind of general to everything. Imagine in our transportation game, let's say that vehicle had a toString method, train had a toString method, and monorail had a toString method. Oh, sorry, I climbed down the wrong way. Car extends automobile, extends vehicle, extends object. 4 toString methods are defined there, one in each of those classes. Well, if we created a vehicle object, the toString method there is specific to vehicles, whereas the object one is kind of general. If we created an automobile object, the one there is specific to automobiles, and whereas the one in vehicle is kind of general to all vehicles, the one in object is general to everything. If we created a car object, the toString method in there is specific to cars, whereas, again, going all the way up to the hierarchy, the one in object is just kind of general to everything. So if you create a car object, the toString method called is the most specific one, or the one furthest down the hierarchy. And there are ways to call the others. We're going to not see that. Right. Blah, 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 blah. Yes, I think I said that. So this, by the way, is called overriding. Overloading we saw. Overloading is like the plus operator. It can add ints together. It can add floats together. It can stick strings together. Right? That's overloading. This is called overriding. The toString method that was in the object is completely overridden by the toString method in vehicle. That's overridden by the toString method in automobile. That toString is overridden by the toString method in car. Okay. Questions? All right. So as I said, I like to spend a bit of time reflecting back on the class. This is my 6th semester teaching CS101, and actually it's going to be my last for some time. They like to rotate people through the classes that they teach every 2 or 3 years. So for me, this class has been a progression over 6 semesters, and although you just see, obviously, the this semester snapshot of it, from my point of view, it's obviously changing quite a bit as every semester I try new things and add on things and, quite frankly, give people more homework. So we had the demotivator winners. Everybody voted on their demotivators in Lab 12. So if you got voted first place for demotivator, it got 3 points. Second place, 2 points. Third place, 1 point. And what I expect to do is I'll buy a pair more demotivators, put them up there so I can appropriately demotivate all the people next semester. I will tell you right now, some are really not appropriate for my office, like failure, right? Probably not appropriate for a teacher's office. Yeah, well, luckily there's almost 100 of them, and there's a lot of others that are appropriate. So these are the results as of 2 p.m. today. And we had 334 of 359 precincts reporting, so about 93%. This lecture, this part is going to be a bit schizophrenic because I'm going to flip between the somewhat serious stuff I want to go over and the demotivators. So, course reflection. There were actually 6 in 8th place, and 1 each in places 7th through 1st. Underachievement, the tallest blade of grass is first to be cut by the lawnmower. So there were a number of course goals, and course goals are put there for a specific reason, partly because we want you all to know to some extent what you're getting into, what you're going to learn. We have accreditation issues and fun stuff like that. So after finishing this course, you should understand the fundamentals of programming, such as variables, conditional, and iterative execution, i.e. if statements and loops, methods, etc. This is the only slide I actually read from. Understand the fundamentals of OO programming in Java, object-oriented programming in Java, including defining classes. We've seen lots of that. Invoking methods, meaning calling methods. Using class libraries, java.util, etc. Be aware of the important topics and principles in software development. We did do that, but not, and I'm going to sort of wrap that up in a bit. We ended up doing that to some extent. It just wasn't as sort of overt. Have the ability to write a computer program to solve specified problems. It's kind of like every lab and every homework and exams. And be able to use the Java Software Development Kit environment to create, debug, and run simple Java programs. These are the course goals that sort of guided the progression of this course. And 8th place also is dreams. Dreams are like rainbows, only idiots chase them. Not so much. You voted for them. So there are a number of sort of unstated course goals, really in any course. And one of them is that everybody needs to have sort of a base level of computer programming proficiency. And it doesn't necessarily mean that you're ever going to program in Java again. But there are things you're going to be programmed. Maybe you end up creating a macro in Word, or you use MATLAB. But the process of going through it and thinking logically, understanding loops, understanding ifs, that's sort of the basic level of computer proficiency that certainly all computer scientists need so they can move into the next class, but engineers as well, and there's a lot of other majors outside the engineering school where it's deemed that they should know that as well. To a certain extent, the language you know is not as important as the topics. Obviously, this was in Java, but the things like ifs and loops and arrays, those are things that are really going to be in just about any language you use. 101 provides sort of the base level of that, and 201, of course, is going to expand upon that. Also in 8th place, success. Some people dream of success while other people live to crush those dreams. So, as I said, a lot of things change from one semester to the next. Each of the homeworks and tests always has to be different. So, because what happens is there are large groups, or there are groups that will collect exams from various people from various years, and this way the people in that group have access to previous year's exams, and if we reuse it, they see the exam ahead of time. This is called the fraternity file effect, although it's not just fraternities or sororities that do this. There's many groups that do this. So in an effort to make a completely level playing field, what we do is we create all new exams and all new homeworks every semester. This is why, well, one of the reasons why there often are issues with the homeworks, because we don't have many semesters to perfect them. We're kind of doing it off the seat of our pants. The course project, being as the homeworks are different every semester, the course project is obviously a new one. We've done a space trading game, we did Battleship, we did a dungeon crawl, and of course this semester we did Oregon Trail. Then there's a number of things that we improved upon that I started in the fall and I improved upon. This is the second semester of videoing the lectures. I think it's gone a bit smoother this semester. The clicker response system, believe it or not, was improved. I'm going to get to that in a minute. Using cs101 email, at least that was an improvement for me. We had a different textbook this semester than the previous. And anytime you change textbooks, there's always some bumpiness. And I know the textbook, not everybody loved the textbook, but the general impressions of people from the textbook were much better this semester than last semester. People last semester would rave on how much they disliked it. This semester, I haven't heard much dislike of it. And to a certain extent, I know the lectures didn't totally correspond with the textbook, though it was fairly close. I wanted it to be a slightly different perspective. But the general impression seemed to be that the textbook was much better this semester than last semester. I won't fully know that until I get my toolkit evaluations back, because that has the textbook question listed in it. We only had one grad TA this semester, whereas in the past we've had like half a dozen. And this created quite an interesting strain. There was there's all sorts of discussions between me and the department where I threw mini hissy fits and major hissy fits about this. But that caused a lot of the work that is normally done by the grad TAs to be offset onto the undergrad TAs. It used to be there was always one grad TA and a couple undergrad TAs in the labs. This semester, of course, all but one of the labs had only undergrad TAs running them. As you probably have noticed, the undergrad TAs, some of them have been TAing for me. They're in their 5th semester TAing for me with this specific class. So they've gotten through and done they have a huge amount of experience doing it. Consistency, it's only a virtue if you're not a screw-up. So there's some things that didn't work quite as well this semester as we had hoped. Clickers. So here's the thing, is I truly believe that if the clickers worked, it would be great. It would enable me to, I mean, the problem is I see this mass of people, and it's hard for me to judge how well things are soaking in when I have trouble focusing on the people in the back row. And that's something that clickers do, is it allows it to be anonymous. I can say, you know, who understands it and have people raise their hands, but it's really hard then to pick out who's not raising their hands. And if I say who doesn't understand it and have people raise their hands, then nobody wants to be, you know, of the few people who don't understand it. So clickers allow an anonymous way for me to figure out, or pseudo-anonymous way for me to figure out who is, you know, how well people are understanding things, and then I can adjust the lectures, re-explain things, et cetera, et cetera. Obviously, it would work much better if the darn things worked. Believe it or not, it's much better this semester than last semester. Clickers are something that the university as a whole is looking into, and the idea is to try to standardize the clicker system because every class wants something different. We have sort of standardized on the particular one we used this semester, because I know many of you had it from Chemistry 151. And that was a big reason we chose it, because this way those people at least wouldn't have to buy a new clicker system. So part of the problem is none of the clicker systems are compatible with each other, and they're more interested in getting more people to buy their clickers than having their current systems work as well as they did. So I do feel bad that, you know, you all spent 40 bucks on something that didn't work quite as well, but for the couple times it did work, I was pretty happy with it. Grading, we generally were pretty good at getting the grades returned in a quick amount of time up until homework 7. And that was sort of the big problem, is homework 7 just took an insanely long time to grade, and you notice it's still not returned. It's taking somewhere like 20 to 30 minutes per assignment. This is why it hasn't returned. And you multiply that by 360 people, you're talking about 120 hours. That's 6 hours per TA, and these TAs are doing a lot of other things at the same time. Actually, no, it's like 7 or 8 hours per TA. So this is why homework 7 has been delayed, and it sort of created a domino effect. This was largely my fault. I didn't, all this is my fault, right? Anything that goes right or wrong with the class is certainly my fault. But I certainly didn't anticipate it would take that long. But that sort of created the domino effect that's caused everything else to be delayed. The course project. I actually liked the idea. I think the way it was implemented needed some improvements. This was the 4th semester we've done the course project. It was Dungeon Crawl, Space Trader, Battleship, and then Oregon Trail. And I think in hindsight, there are a couple things we realized we probably could have done better. In general, I like lowering the amount of student frustration. My goal is to make you work hard, not to make you work frustrated. There was, I have a series of humor breaks that I bring in, and some of them are just really, really funny. Some of them, you know, enough. I mean, the point of the humor breaks, of course, is to sort of get your attention off whatever I'm talking about and have your mind sort of reset a bit. Some ended up not being quite as funny after the Virginia Tech tragedy, and I ended up not bringing it in. I have this fluorescent purple marshmallow gun that in another semester, the students loved it. I bring it out, I could spray the first 5 rows with mini marshmallows. not quite as funny after Virginia Tech. Or something that talked about the rivalry between Yale and Harvard, which sort of mirrored the friendly rivalry between us and Virginia Tech. So there were a number of humor breaks that I had planned, but then had to quickly change. Indifference. It takes 43 muscles to frown and 17 to smile, but doesn't take any to sit there with a dumb look on your face. So that being said, there were a lot of things that did work very well this semester. The videos of lectures, I got a lot of good feedback, even though they were watching My Ugly Mug. I got a lot of good feedback about the fact that the videos were up there and people could watch them when they ended up missing lecture. As I said, the clickers, there were lots of problems. When they did work, at least the feedback I got was great, using cs101 email. The textbook, I think that worked much better than in the past. There are still issues to work out with that. I mean, obviously, I'm not going to be doing that since I'm not doing 101. I think the assignments were, the ideas we came up with the assignments were fairly creative. It becomes difficult to always come up with, a dozen new assignments every semester. And I thought that a lot of the ideas that we came up with were fairly creative, and I was kind of happy with them. Keeping a class of 360 people moving in a regular basis is not really a trivial task, perhaps not surprisingly. I think that works well. And there were a lot of things that were sort of behind the scenes. The TA organization utilization, I have 17 undergrad TAs, and keeping them organized is something that took a lot of work. As you can probably tell from the course, I'm an organization freak, and I like to have my courses nice and organized. This is why the grading drove me up the wall, because suddenly everything was nice organized except the grading, which just sort of all fell apart with homework 7. The grading system, though, works well. The web server only crashed a couple times. That's much better than the past when it was down for days, literally. I think I did a better job of delegating some work to the TAs. The class size was smaller. There's only 263 people registered for this section. And while that may sound a bit odd to say, 2 years ago I had 415 in this room. Not surprisingly, smaller classes are better to teach anything to, much less computer programming. The goal is to lower the class size to make it much, much smaller. It's a start. In 8th place also is laziness. Success is a journey, not a destination, so stop running. No, not so much. So the big question is, did I push too hard this semester? And everyone groans, like, oh, my course. So I obviously did push the class hard this semester, and intentionally so. But the question is, did I push too hard? So consider this. I've gotten as many, if not more, things are going great, but they're really hard, as I have things are just way too hard. Homeworks, on average, took about 6 hours. Now, that's, of course, averaging across all, really 9 homeworks, right? I don't have the results for homework 10. And that's just the results from the survey. And so there were 10 homeworks over 15 weeks of the semester. And that's about, on average, 4 hours per semester. I'm sorry, 4 hours per semester. 4 hours per week for our homework. So from Lab 12, the surveys I got from Lab 12, this class required about just under 6.7 hours per week outside of lecture, whereas other courses required about 7 hours. So it depends on how you want to look at it. I don't think I pushed too hard. I think what happened is that there was a lot of frustration in how I pushed. And I think that was really the kicker of it. Or maybe I'm off in left field here. But I think the problem was more the frustration with in how hard I pushed, rather than just the fact that I pushed too hard. Because at least from these numbers, this course actually required less work than a lot of other courses. I am very interested in your feedback about this, but not now. Just because I have a lot of stuff a bunch of stuff I want to get to in the next 10 minutes before I leave you forever. If you do have comments, please send me an email or feedback, anonymous, non-anonymous. I'm definitely very interested in your feedback on this. In 7th place, idiocy. Never underestimate the power of stupid people in large groups. So I wanted to wrap up by talking about sort of the big object-oriented programming picture. We've seen many little parts of this. I'm hoping that these next half dozen slides or so will help collect all of that. Individuality, always remember that you are unique just like everybody else. So you created about a dozen or so classes. Granted, the game was given to you, and I think we gave you control because there were just too many classes to split into assignments. But one of the great things I like about the course project is it takes a big task, program Oregon Trail, and splits it down into a dozen classes, and then, or we split it down into a dozen classes, then we assign one class to you at a time. And this shows a number of things, but it shows how you can take a big thing and split it into smaller things. In particular, take a big programming assignment and split it into, in this case, a dozen different classes. And these were all the classes that you implemented in the last 4 homeworks, and I guess it was the last 3 or 4 labs. Ambition, the journey of 1,000 miles sometimes ends very, very badly. That was actually a real picture. That's not photoshopped, or so I'm told. So notice how the classes interacted in the game. There's only one location class. There's only one depot class, but you create, 100 location objects, maybe a dozen depot objects. Each depot has its own inventory object. So even though in the beginning of the semester, in fact, on one of the early tests, I said, what's the difference between classes and objects? I would argue that now you have a better understanding of it because you created the one location class. And in your game, it went about and created a slew of location objects. Similarly for the depot or any of the other classes. The class is what you actually write, but you create a dozen, 2 dozen of them, 100 of them somewhere in the game. So location for each spot on the map grid, you have a bunch of depots there, et cetera, et cetera. And it's the objects interacting that's really the key to object-oriented programming. If you created a great big OOP program, you would create some class, and some objects would be created of it, and it would interact with other objects in the game. Maybe you would create the depot class, you would create the location class, you would create the inventory class. They would all happily talk to each other in their computer worlds. Wishes. When you wish upon a falling star, your dreams can come true. Unless it's really a meteorite hurtling to the earth, which will destroy all life. Then you're pretty much hosed no matter what you wish for, unless it's death by meteor. So once we hit the 4th place, that's when the laughs start coming. So continue on in how all of the things interact. We had this whole animated slide that you notice I'm really using pretty much as I can. It took me forever to do this animation, okay? And you'll notice that, again, there's still only one location class, but here it shows 4 location objects, multiple depot objects, 3 inventory objects, a couple person objects, and this is really how the class interacts. And even in more advanced object-oriented programming, you will see diagrams like this, because these diagrams, I think, really help clarify what's going on and what's intended and where all the arrows are pointing to. So this is largely, a lot of these sort of advanced object-oriented aspects is understanding how all these objects interact with each other, how the one class creates the many objects, et cetera, et cetera. Right. We'll go through the animations. In 3rd place, persistence. It's over, man. Let her go. I don't know if they sell this as a poster. I would have had this up long ago in my office, but because I run and some people I've ran with have just, it would kind of look like that except I was over there. But I don't know if they sell this as a poster. Anyway. So in general, if you want to solve a problem in computer science, or really a lot of the rest of life, but in computer science, you take the problem and you split it down into smaller and smaller pieces. So a big program is split into packages. I mean, this is a huge program, right? Bigger than what we've done in this course. You split it into packages. Maybe one programming group does one package, the next programming group does another package. Well, we haven't really seen packages yet, right? I talked about it a little while ago, but we really haven't seen it too much. We can consider the game to be one package. Then you take that package and you split down that into hierarchies. hierarchies being some sort of object-oriented hierarchy. Uses inheritance. We didn't know inheritance when we first started talking about the game, so we kind of skipped that step as well. Hierarchies are broken down into classes, right? Any hierarchy is going to be some diagram listing how all these classes relate. Our game, for example, had 12 classes. Each class is broken down into methods or behaviors and variables or properties. Some of them, like map printer, they only had a few. Location had a couple dozen. And then each method is broken down into parts. And you'll notice that at each step, we're taking a problem and breaking it down into successively smaller tasks until you get the small tasks, and those are things that you can actually tackle. Any of us can easily write a method, but if we were just given some huge program, it would take us some time to sort of break it down into the part where we can start actually writing code. And indeed, when you have really big projects, and this is, once people are graduated and working in the computer field, a lot of the time spent is actually sort of the planning of how to properly break things down. That's what a lot of the computer science theory talks about. How do you plan? How do you properly break things down into classes, into hierarchies, into packages? In second place, procrastination. Hard work often pays off after time, but laziness always pays off now. I would happily put this up in my office. I have that pad as my, I got it when I was getting my PhD because that's what people do when they get their PhDs, they procrastinate. So the completed game, this could easily be done, split among many people to work on it. For example, each person writes a different class. You can have 12 people all working on it at the same time, each writing a different class. Now, granted, some classes were harder than others, right? The person who has map printer is going to be done fairly quickly. Well, maybe map print's not a good example. Parser is going to be done fairly quickly, but the person who's doing location is going to be taking a lot more time. So it's not exactly equal. But the idea is that is one way to start breaking things down among many people. Our game was over 1,000 lines. Now, granted, we had really long-winded comments because the text you saw in the Java documentation is included in the comments. But even so, it was still over 1,000 lines of just code. And even if you didn't get some stuff working, you ultimately still wrote a 1,000-line program. And that's pretty good for a CS1 class. Right. In particular, what was really important there is that you saw all the parts. You saw how all the parts interact, and were able to create, through the various steps that we led you through from homework 7 to 10, we were able to create all the various parts of the assignment. So the winner, with 94 votes, which is almost half again as much as the previous one, was... Oh. I'll come back to that. Potential! Not everyone gets to be an astronaut when they grow up. Have a great summer break, everyone. I love that one.